Hi. I'm really curious just to hear about something recent you've done, like just solving a problem. I don't like not necessarily anything large, but just interesting thing that you've done recently and how you did that.
Ben, real quick, can you introduce yourself? Say
Oh,
your where.
yeah. I'm Ben Aubin. I'm a hack club leader in the DFW area, and I do a lot of programming and stuff.
All right, cool. Let's see. Probably like the biggest issue I have is like context switching, because I got like so many things going on here at SpaceX and Tesla and Neuralink, Boring Company, your personal stuff. The thing that I find is like quite taxing my brain is the context switching. But that is what I'm probably having the most trouble with. But because there's so many problems that occur during the day, and I'm actually really deep feeds on so many things. It's pretty ridiculous. So let's see, like last night, and this was, I don't know, 2 or 3 a.m. or something. I was in the tent 2 of the Starship production complex at the barrel welding station, and we were, for the circumferential welds of the ship, we're seeing a little bit of pucker where the weld's puckering in a little bit. You can see it on the, it's pretty obvious online. I mean, it used to look like the Michelin Man, so it's way better than it was. But we're still getting a little bit of pucker, and the welds are going a bit slow. So I was out there just talking with the welding team, and I think it was like the issue was like really we're rotating the barrel only at a quarter meter per minute, but the barrel rotation tool is capable of 1.5 meters per minute, and the welding torch was not set at maximum power, and so the result was that we were heating the steel too much, and it was softening, and then just slightly collapsing under its own weight, because it was softening. So when you do a weld, you really want to have a high energy density weld to be just right there. You want a tight gap, high energy weld, and you don't want to heat up the parent material, because it, like I said, it's going to soften a little bit and kind of pucker, and that's bad for buckling. You don't want to have a buckling initiation point. And then and then yes, so that's what I was working on last night as an example. Then it was like, okay, guys, experiments, because they were worried about like changing the parameters and then maybe having to scrap barrels. And these are barrels that are 9 meters in diameter, or 30 feet in diameter, basically. And you have 2 of them, and so they're like, well, we don't want to scrap the barrel. We're worried about changing the settings. But it's like, okay, but let's just have some fun here and try some experiments, because otherwise nothing ventured, nothing gained. So they're like super excited about that. And in fact, right after this call, I'm headed out there to see the results. And I think we kind of messed up half the weld, but I think the other half is good. And so and then we'll end up with a faster weld that is less heat input into the material, which causes less dimensional variation, because you've got 300 series stainless has pretty high coefficient of thermal expansion. So so when you warm it up, then the gap changes, like, because it's metal expanding. So we want like tight gap, a hot weld, move fast, and then we have a good joint.